Good morning, everyone. So welcome to my YouTube channel, Maths Arjuna. So today we are going to see seventh lecture on asymptotes of curves. Today we are going to see how to find oblique asymptotes for a algebraic curve fxy is equal to 0, which is not solvable explicitly as function of y as a function of x or x as a function of y. Okay. Oblique / inclined asymptote of an algebraic curve fxy is equal to 0, not solvable explicitly as y is equal to function of x or x is equal to function of y. Okay. So we'll do this today. Okay. So arrange the terms arrange the terms in the given equation fxy is equal to 0 as fxy is equal to a naught x to the power n plus a1 x to the power n minus 1 y plus a2 x to the power n minus 2 y square and so on plus a n y to the power n bracket close plus b naught x to the power n minus 1 plus b1 x to the power n minus 2 y plus b2 x to the power n minus 3 y square, okay, up to bn minus 1 y to the power n minus 1, okay, plus and so on plus p naught x plus q1 y plus q naught is equal to 0. We can always write algebraic curve like this, okay. So now we can write this as, or we can write fxy like this. You take x to the power n common. So what you will get here? Plus b naught b1 y upon x plus b2 y upon x square bn minus 1 y upon the power n minus 1. Okay. And so on plus x you take common p naught okay p naught q1 y upon x plus q naught, okay. is equal to 0. Or now we can write fxy is equal to x to the power n phi n y upon x plus x to the power n minus 1 phi n minus 1 y upon x, okay, and so on, x phi 1 y upon x plus 2 naught is equal to 0. Okay, we can write. So we have phi m y upon x m goes to 1 to up to n are polynomials of degree m in y upon x, okay, in degree y upon x, in y upon x, okay. Now, let's say this equation star. I'm calling this equation as a star. So dividing the equation star by x to the power n, we get phi n y upon x plus 1 upon x phi n minus 1 y upon x plus 1 upon x square phi n minus 2 y upon x plus 1 upon plus 1 upon x to the power n 2 naught is equal to 0. Let's say it's double star. Okay. Now let y is equal to ax plus b be an oblique asymptote. Okay. Let the oblique asymptote of the given curve. Okay. So we need to find a and b. Okay. We need to find a and b. If we can find values of a and b, then we will find this is the asymptote, oblique asymptote of the given curve. We need to find it somehow. Okay. So we have this asymptote y is equal to ax plus b. Y is equal to ax plus b we have. So dividing by y upon x, what we will have? We will have this one. So for oblique asymptote, we have x tending to plus minus infinity. So what we will get? We get limit x tends to plus minus infinity y upon x, where it will converge to a. Okay. So when x tends to plus minus infinity, y upon x is tends to a. So now taking limit as x tends to plus minus infinity in double star, we get what we get? We get phi and a, because y upon x converts to a, and next part will be 0, because in denominator there is a x, and we are letting x tending to infinity, so it will be 0, this will be 0, and so on, this will be 0, and last one will be r. So what we have? Phi and a is equal to 0. Okay. So solving phi and a is equal to 0, we obtain solving phi and a 0, we obtain all possible values of a. Okay. So if phi and a is constant, or no real solutions exist for phi and a is equal to 0, then no oblique asymptote exists for the given curve. Okay, given curve. So we are dealing now, if phi and has real solution, then proceed as follows. Okay, proceed as follows. So what we will do? We have y upon x is equal to a plus b upon x. Okay. Substitute y is equal to a upon x in star, we get what we get? We get phi and a plus b upon x plus x n minus 1, phi n minus 1, a plus b upon x, okay, plus x phi 1 a plus b upon x plus q naught is equal to 0. Okay. Now, expand each term. Now, expand each term. Expand each term in Taylor series about a. We obtain or we get what we get. So x to the power n phi n a b upon x phi n dash a plus b upon x square phi n dash double dash a. So here is 1 upon factorial 2 also. Okay. And so on. Now next one, you take expansion on next term until let's say phi n minus 1 a plus b upon x phi n minus 1 dash a plus 1 upon factorial 2 b upon x square phi n minus 1 double derivative a and proceed like this. Next, x to the power n minus 2 phi n minus 2 a plus b upon x phi n minus 2 first derivative at a 1 upon factorial 2 b upon x square phi n minus 2 double derivative at a and so on. Last, proceeding in this way, last term is x phi 1 a plus b upon x phi 1 dash a plus 1 upon factorial 2 b upon x square phi 1 double dash a and so on, plus last term is constant q naught plus q naught is equal to 0. Because a is solution of phi and a. So substituting, setting phi and a is equal to 0. Phi and a is equal to 0 and writing equation in descending power of x and dividing by x to the power n minus 1. We get what we get b phi n dash a plus phi n minus 1 a. Okay. Plus 1 upon x b square upon factorial 2 phi n double dash a plus b phi n minus 1 dash a plus phi n minus 2 a. 1 upon x square b cube upon 12 phi n triple dash a plus b square upon factorial 2 phi n minus 1 double dash a plus b phi n minus 2 derivative a plus 5n minus 3a bracket close and so on, it is equal to 0. Taking limit and extending to, let's say this triple A star. Okay. So taking limit as x tends to plus minus infinity in triple A star, we get what we get b phi n dash a plus phi n minus 1 a is equal to 0. Okay. We got this. Okay. So case 1, if phi n dash a is not equal to 0, then b can be determined by b is determined by b is b is determined by so you determined by in this case phi we have this one. Okay. So this implies b phi n dash a is equal to minus phi n minus 1 a, because phi n dash is not 0, so we can divide. B is equal to minus phi n minus 1 a phi n dash a. So we can be determined by this way. Okay. Okay. So corresponding to A, the value of B can be determined by B is equal to minus phi n minus 1 A upon phi n dash A, provided phi n dash A is not equal to 0. If phi n dash is not equal to 0, then we can determine our value B by this formula. Okay. Okay. So this is the formula. Case 2, if phi n dash A is equal to 0, but phi n minus a is non-zero, then no oblique, then what we have, then put these values in this formula, b phi n dash a plus phi n dash minus a is equal to 0. So putting these values in here, so this part will be 0 and this will be phi n minus, which is not possible, which is not possible. Okay, as phi n dash a is non-zero. Therefore, in this case, no oblique asymptote exists. No oblique asymptote exists. Okay, exists. Exists. Now, case 3. If phi n dash a is equal to 0 and phi n a is equal to also 0, then by equation triple star, we get what we get. What was the triple star equation? Triple star equation was this one, p phi n dash a plus phi n dash minus a, okay, this one, plus 1 upon x b square upon factorial 2 phi n double dash a plus b phi n minus 1 dash a phi n minus 2a plus 1 upon x square b cube upon factorial 3 phi n triple dash a plus b square upon factorial 2 phi n double dash a plus b phi n. Okay, phi n minus 1 and phi n minus 2 a plus phi n minus 3 a and so on is equal to 0. But phi n dash 0 is phi n minus 1 is 0. So what? So setting phi n dash is equal to 0 and phi n minus is equal to a 0. We get what we get. Setting this and multiplying by and multiply by x. Okay, we get what we get. B square upon factorial 2 phi and double derivative at a plus b phi and minus 1 derivative at a phi and minus 2 a plus 1 upon x square b cube upon factorial 3 phi and triple derivative at a plus b square upon factorial 2 phi and minus 1 double derivative at a b phi and minus 4 derivative at a plus phi and minus 3 at a. Okay, so this is 3 like that, and this is 0. So letting x tending to plus minus infinity, we get, okay, what we have? We have b square upon factorial 2 phi and double derivative at a plus b phi and minus a plus phi and minus 2 a is equal to 0. Solving this we get two real solutions. Okay, real solutions. Okay, so again, if phi and double dash a is not equal to 0, then again we can discuss roots of solutions of the just above equation and discuss several corresponding cases. Okay, so if the above equation has real solutions b1, b2, then we have parallel asymptotes corresponding to A. What are those parallel asymptotes? Ax plus b1 and y is equal to ax2 plus b. Okay. Again, okay. So further cases can be, so again, if phi n double dash a 0, phi n minus 1 dash a 0, and phi n minus 2 a 0, then we will solve the following equation obtained from triple star in similar manner. What is that equation? B cube upon factorial 3 phi n double derivative a plus b square upon factorial 2 phi n minus 1 double derivative as a b phi n minus 2a single derivative phi n minus 3 as a is equal to 0. So we proceed. So this method continues in similar manner and after certain steps, it terminates. It means we reach to a conclusion. It means we reach to a conclusion. Okay. Okay. So it will be clear by example. So now we are going to see examples. So example 1 we are taking. So we are taking the following examples. Example 1. Find all the vertical asymptotes, oblique asymptotes. Oblique asymptotes of the given curve. What is the curve? Y square x minus 2a x minus 2a 2a x cube minus k cube, where k is greater than 0. Okay. So y square x minus 2k we have, and then x cube minus k cube. So solve this equation. So we have xy square minus 2kx x cube minus k cube. So this is xy square. So x cube minus xy square. Okay. Plus 2kx minus k cube is equal to 0. So this implies x cube minus xy square plus, okay, 2kx minus k cube is equal to. So what is highest degree here? Degree is 3. So we collect all the terms of highest degree and we are calling this phi 3 as degree is 3. So how to obtain? Phi 3a? You take highest degree terms collect here. Okay. So you take highest degree terms here, collect here all the highest degree terms here, put x is equal to 1 and y is equal to a. Then put here x is equal to 1 and y is equal to a. Then what will be phi 3a? This is 1 minus a. And what is phi 2a here? Because phi 2x is phi 2x, no, there is no second term, so there is 0. And what is phi 1a? So this is 2kx. You put in place of x, you put 1. So 2k. Okay. So for oblique asymptotes, we will solve this equation. Phi 3a is equal to 0. So what is this? 1 minus a square, this is 0. So a is plus minus 1. So we have two values, a is equal to 1 and a is equal to minus 1. Now, what is a is equal to 1 we are taking and we will find the corresponding oblique asymptote. So phi 3 dash, what is this? Phi 3 dash is minus 2a. So what is phi 3 dash at 1? What is this? Minus 2. So we will, phi 3 dash is non-zero. Phi 3 dash 1 is non-zero. So we have value b. How to calculate value of b? That is minus phi 2 dash 1 upon, sorry, phi 2 a, phi 2 1 upon phi 3 dash 1. But phi 2 a is 0. So this will imply phi 2 1 is also 0. So this is 0 upon minus 2, that is 0. Okay. In this process, when you will calculate oblique asymptote, automatically horizontal asymptote may come. Okay. So what is, now you got this one, ax plus b. What is this? Y is equal to 1x plus 0. Okay. So this is one oblique asymptote. Okay. So we got this one. And what a is equal to minus 1? What is this? Phi 3 dash at minus 2. It is minus 1. What is this? Minus 1. What will be this? It will be 2. Okay. Now b will be minus phi 2 1 minus 1 upon, and that will be phi 3 dash minus 1. So what will be this? This will be actually 0. Because phi 2a is 0. So this implies phi 2 minus 1 is also 0. So what we got? Y is equal to ax plus b. We put the value minus x plus 0. This implies y is equal to minus x. Therefore, y is equal to x and y is equal to minus x are oblique asymptotes for the given curve. Okay. So example number 2, find all the oblique asymptotes for the given curve y square k square minus x square k cube x, where k is greater than 0. Okay. So write this equation in highest degree. So y square k square minus x square k cube x. So we can write this x square y square minus y square k square, okay, plus k cube x is equal to 0. So x square y square minus y square k square k cube x. What is 54a? Because degree, highest degree is 4. So 54a, what is this? When we calculate 54a, we always put x is equal to a, x is equal to 1, or y is equal and y is equal to a. So when it is the highest, so it will be a square. And what is 53a? 53a 0. And what is 52a? 52a will come from there, that is minus a square k square. Okay. And what is 51a? That is k cube, because x is equal to 1 you will put. So for oblique asymptote, we solve, what we solve? We solve this 54a is equal to 0, we solve. So what we'll get? So a square is equal to 0. So what is a is 0, 0. Okay. So what is 54 dash a? That is 2a. This implies 54 dash at 0 is actually 0. So this implies to calculate the value of p, we need this. So this implies the values of v will be calculated by this formula. So what is this? 54 double dash a. It means 54 double dash at 0. B 53 dash at 0. 52 dash double dash at 0. So what is 54 double dash a? That is 2. So this will be b square upon factorial into 2. What is this? Is 53 dash 53, actually 530, so its derivative will be there. And what is this? 52a? Phi to A is nothing but minus A square K square. A square K square. Okay. Phi to A. Okay. A square K square. So 2 is cancelled out. And this is B square minus A square K square is equal to 0. So this will imply B is equal to plus minus AK. It means B is equal to AK. But what is the value of A? Sorry. What is the value of A here? What is the value? So phi to A is also 0. This is also 0. Because value of A is 0, no? Value of A is 0. So this is 0. So this implies B square is equal to 0. This implies B is 0 and 0. Let me check it again whether this is okay or not. If I say 0 and this is phi to A is 0, so B goes. So B is 0. So what is this? So this implies Y is equal to 0 AX plus B. So this is 0 into X plus 0. Y is equal to 0. So sometimes whenever we going to find oblique asymptote, it may because of A and B 0, we will go horizontal asymptote. This is horizontal asymptote. So what does it mean? Whenever we are going to find a oblique asymptote, we are getting here horizontal asymptote. This implies no oblique asymptote. Okay, no oblique asymptote exists for the given curve. Okay, we are going to solve another question. Example 3. Find all the oblique asymptotes for the curve given y. That is the curve x square y square k q square y square minus x square, where k is greater than 0. Solution. So we can write this like this. Okay. Okay. So what is phi for here? Phi for A. Phi for A is here. You put x is equal to 1 and y is equal to this is A square. And what is phi 3A? That is also 0. Is phi to A is 1 minus A square A square. Okay. So what is for oblique asymptotes? Solve 5 for a is equal to 0. It means a square is equal to 0. This means a is 0, 0. So we know that again 5 for dash is 2a. It means 5 for dash at 0 is 0. So we will calculate b value by this formula. 5 for double dash at 0 b 5 3 dash 0 5 2 dash 0. So what is 5 4 dash? This is b square upon factorial. So it is 2 and this is 0. And what is 5 to a? What is 5 to a? 5 to 0. What is that? 5 to 0 is nothing but k square. K square. So this and this cancel out. B square, k square is 0. B square is equal to minus k square. B is equal to plus minus ki. Okay. So we can explain this by 2 ways because B is a complex number, so no vertical oblique asymptote. Actually, a is equal to 0. Therefore, no oblique asymptote exists. Asymptote, no oblique asymptote don't exist. Okay. Since B is plus minus ki, not real, therefore no horizontal asymptote also exists. In this way, we explain 2 things. We know that A is 0, so no oblique asymptote exists. But B is going to be a complex number that is not real. It means no horizontal asymptote will also exist. Okay. So there are 2 explanations here written. Okay. So now we are going to take another example. Example 4. Find all the oblique asymptotes oblique asymptotes of the given curve y minus 2 x square minus 1 is equal to 5. Solution. Solve it. So what is this? After solving it, what you will get? X square y here. Okay. Minus y. Then 2x square plus 2 is equal to 5. So bring 5 from the to left side. So what is 5 here, 3a here? That is a. 5 to a is here minus 2. 5 1 5 1 a is equal to minus a. Okay. For oblique asymptotes, so we have 5 3 a is equal to 0. It means a is equal to 0. Now 5 3 dash a is not equal to 1. That is not equal to. So how to give value of b value is given by minus 5 to a upon 5 3 dash a. What is this? 5 to minus. So what is this? B is equal to minus 5 to a upon 5 dash 3 a. Sorry, this is 0. A value is 0. So what is this? So this is minus 2 minus 2 upon 1. B is equal to 2. So y is equal to 2. So b is equal to 2. So what we have? Y is equal to ax plus b, that is 0 into x plus 2. This is a horizontal asymptote. This is horizontal asymptote. So no oblique asymptotes exist. Okay. So today's lecture to this, if you have any problem related to this, you can comment on my channel. Like, share, comment, and subscribe my channel. So thank you very much for today's lecture. Thank you very much. We will continue solving such type of questions based on oblique asymptotes. Okay. So we'll find many questions solved on my YouTube channel. Okay. So thank you very much for today's lecture.